The main purpose of this video lecture is to emphasize the importance of rectangular strips in applying the definite integral in the different applications of the definite integral. Okay, so I'm going to solve some problems to give emphasis rectangular strips. The first problem is this. Find the volume of the solid generated by revolving about the y-axis, the region outside the curve y equal to x squared, and between the lines y equal to 2x minus 1 and y equal to x plus 2. Okay. Now, to have an accurate graph, let us first determine the points of intersection of the different curves. Okay. So let us say y equal to x squared is, let's denote it as curve number 1. Y equal to 2x minus 1, curve number 2. And this one, curve number 3. Okay. So before we will graph, let's draw a line, vertical and horizontal line. Okay. Let us first determine the points of intersection. Points of intersection. Okay, so let's consider 1 and 2. Okay, so for curve 1 and 2, let's equate y. Y equal to y, so we have x squared equal to 2x minus 1. And we transpose this, transpose the left side, and we have x squared minus 2x plus 1 equal to 0. Okay, and by factoring, we have x 1 minus, and we only have x equal to positive 1. Now, if this is the case, that you only have one point of intersection, it means that this line is tangent to the parabola at x equal to 1. We only have one point of intersection. So, x equal to 1 is a point of tangency. Okay. Oh, x equal to 1. The value of y is also equal to 1. Well, when x equal to 1, y is equal to 1. So okay. It's a point of tangency. Now, if we consider 1 and 3, 1, y equal to y, so we have x squared equal to 3, x plus 2. Transpose again, you have x squared minus x minus 2 equal to 0. And by factoring, factors of 2, you have 2 and 1. And since we have negative x, negative and 2, para bigger siya, and plus. And so we have x equal to 2 and x equal to negative 1. Okay. And to solve for y, when x is equal to 2, y is equal to 4. By x squared man, when x is equal to 2, 4, or simply when x is equal to 2, y is 4. Pag negative 1, it's 1. So they will intersect at negative 1 and 1 here. And the other one is when x is 2, 4. 2, here. Or okay, there na. 4 na. Okay. And then for 2 and 3, okay, equate 2 and 3, you have 2x minus 1, x plus 2 equals x plus 2. So transpose 2x minus x, you have 2 plus 1, so x equals 3. Okay, so when x equals 3, y is equal to 5. So x equals 3. There, for example. Sorry, 3, 2, 1, negative 1. Okay. So, sige. This is the parabola. Okay. Okay. This is the parabola y equal to x squared. And then the parabola and curve 2 will intersect at negative 1, 1 and at 2, 4 here. And so we have this one. Okay. And for curve 2 and 3, they will intersect at 3, 5. So, there na lang. 3, 5. And what's the graph of equation 3? This one is, or curve number 3. This is curve number 2. Y equals 2x minus 1. For curve number 3, what's the plot of this? Okay. 1 and 2. Sorry, this is 1 and 3 ba? 1 and 3. This is curve 3. This is y equal to x plus 2. Okay. For equation 2, 2 and 1 will intersect at this one, or point at down you see 1, 1. Then, okay. So, the graph is this. Okay. So, the bounded region is this one. Region outside the curve y equal to x squared, outside sa parabola, and between the lines. So, it means na this one. This is the bounded region. Okay? This is 1, 1. 1, 1. So, x and y. We are going to revolve this region about the y-axis. Now, since we cannot use a single rectangular strip because of different conditions, we are going to split this one into 2 regions. So first, let's analyze a vertical rectangular strip. So pag vertical, we have this one. Blue. And the other one is red. Okay. So we all know sa hollow cylindrical shell, because if we will revolve this one, blue and red, about the y-axis, we will get a cylindrical shell. And the volume of a cylindrical shell is equal to height times circumference times thickness. So the height of this is y up minus y down. Okay, y up minus y down, and the distance or the radius is simply x. Now for the red, same lang, y up minus y down. But we have different curves, y up and y down. This is y up minus y down. Still, this distance is x. So our differential volume is equal to this one, height y up minus y down times circumference dx plus the red one, y up minus y down times circumference times thickness. Okay, and so we integrate. We have this one, v equals, okay, integral of the blue one has limits from 1 to 2. Okay, this is dx, and the other one is dx also. For the blue, rectangular strip, the limit is from 1 to 2, and for the red, it's 2 to 3. So this is from 1 to 2. And x manta, then we will replace y by x. So we have 2 pi x. Okay. Our y up for the blue one, for the blue strip, is this one, no? Y up, which is parabola. Parabola ni. So our y is x squared. Y down. Our y down is this one. The equation this line is, this is curve number 2, 2x minus 1. Okay? 2x minus 1. So our y down is this line. That's 2x minus 1. dx. Plus the red one. Integral from 2 to 3. You have 2 pi x. Okay. Our y up is this line. That's x plus 2. Minus y down. Our y down is this line. 2x minus 1 dx. Okay? So we have integral of 2 pi. Let's distribute x now. First, let us simplify this one. You have x squared minus 2x plus 1 dx from 1 to 2 plus integral from 2 to 3. You have 2 pi x. Simplify. X minus 2x. That's negative x. 2 minus negative 1 plus, that's plus 3 dx. Okay. So finally we have this one. 2 pi, diretso na. X squared times x, x cubed, dx. That's x raised to 4 over 4. X times negative 2x. Negative 2x squared. Integrate, that's negative 2x cubed over 3. X times 1, it's x dx. That's plus x squared over 2. From 1 to 2, plus 2 pi. Okay. X times negative x, that's negative x squared, dx, that's negative x cubed over 3. X times 3, 3x. 3x dx, that's 3x squared over 2. From 2 to 3. So you have 2 pi. Okay, let's evaluate. 2 raised to 4, 16 over 4, that's 4. 2/3, 2 cubed, it's 8 times 2, you have 16 over 3. Plus 2 square, 4 over 2, that's 2. Minus lower limit, 1/4 minus 2/3 plus 1/2. Okay. Plus 2 pi negative 3 cubed divided by 3, that's negative 9. 3 times 3 square over 2, that's 27 over 2. Minus lower limit, negative 2 cube 8 over 3 plus 3 times 2 square over 2, you have 6. Okay, so let's use the calculator. You have 4 minus 16 over 3 plus 2 minus 1/4, that's plus 2/3 minus 1/2 minus 9 plus 27 over 2 plus plus 8 over 3 minus 6. 7 over 4, that's 2 pi times 7 over 4. Or simply the volume is equal to 7 over 2 pi. Okay. Mano sa ang volume. Okay. Now, okay. In this one, we are using the vertical strip. Okay. Second option is we will use a horizontal strip now. And let's check if we still have this volume. 7 over 2 times pi. Okay. I-fix na ako ah. Okay. Sige. Let's draw again. It's a parabola. You have this one. Probably you have this. And okay. Point of tangency 1, 1. We have this and this one. That's 1, 2, and 3. Okay. This is our area. The equation of this is y equals 2x minus 1 This one is y equals x plus 2, and then this one y equals x squared. Okay. So let's revolve this area, this region about the y-axis. Now this time, we will analyze a horizontal strip. And again, we cannot analyze just one rectangular strip because they have different conditions. So what we're going to do is, let us again split the area. Split na to. So we have this one rectangular strip, blue, and then we have this red. Okay. So dy, so let's have this point of tangency. For this line, when x is 3, y is 5. And for this one, when x is 2, y is 4. Like for this line, when x is 2, y is 4. Or parabola, when x is 2, y is 4. So for the blue strip, the limits will be from 1 to 4. And for the red strip, the limit will be from 4 to 5. Let's label. For the blue one, okay. This is x sub r, x right, and the other one is x sub l. Yun, ang height niya is y, kilang dy. For the red one, x right and x left. X right, x sub right, and yeah, x sub left. dy. For the blue one, dy also. And volume for a circular ring, dv is pi outer radius square minus inner radius square times dy. Okay, so both of them has an outer radius of x sub r and inner radius of xl. So let's proceed to v. V, integral of this one, pi x sub r squared minus x sub l squared dy from 1 to 4 plus integral of pi x sub r squared minus x sub l squared dy from 4 to 5. Let us start with blue. It's integral of pi. For the blue one, our x right is this line. Okay. Now, to solve for x, our x is simply y plus 1 over 2. Okay, this one. And for x sub l is parabola. So when you solve for x, that's square root of y. Okay. While for this one, x is y minus 2. Okay. So for the blue strip, xr is this one, y plus 1 over 2. So that's y plus 1 over 2 squared minus x sub l. X sub l is y square root of y, or simply y raised to 1/2 yeah, squared dy plus integral from 4 to 5 pi x sub r is this line y plus 1 over 2 squared minus x sub l. X sub l is this y minus 2 squared dy. Okay, so what we're going to do is let's expand from 1 to 4, no? From 1 to 4. Let's expand this one. We have 4. Expansion of y plus 1 squared is y squared plus 2y plus 1 minus y raised to 1/2 squared is simply y plus integral from 4 to 5. Same lang. You have y squared plus 2y plus 1 minus expansion of this y squared minus 4y plus 4 dy. Okay. So simplify again. We have this y squared over 4 and 2y over 4 is y over 2, no? 1/2 of y minus y. You have negative 1/2 of y or y over 2 plus 1/4 dy plus integral from 4 to 5. Okay, let's combine. Y squared over 4 minus y squared. That's negative 3/4. Okay, that's negative 3/4. 1/4 minus 1. Man. Okay. 2y over 4, that's 1/2 of y. 1/2 plus 4. Negative 4 minus negative 4, that's positive. 4y plus 1/2 y. 9/2. And then 1/4 minus 4. That's negative 15 over 4. Ba? 1/4 minus 4. Okay. So let's integrate by integral. Y cube over, so you have y cube over 12. Y squared over 4 plus 1/4 y from 1 to 4 plus pi y cube over 3, makancel ang 3. So you have negative y cube over 4. Y squared over 2, you have 9 over 4. Y squared minus 15 over 4y from 4 to 5. Okay. Para shortcut, let's have this one, no? Y cube or y cube over 12 minus y squared over 4 plus y over 4. 1/4. Let's use calculate. Calc 4. And we have 7 over 3 minus lower limit. Calc 1. 1 over 12 plus pi. Okay. Input side negative y cube over 4 plus 9 over 4 y square. So y square minus 15 over 4 y. Okay. Calc 5, 25 over 4 minus calc 4, 5. Okay, so let's compute. 7 over 3 minus 1 over 12 plus 25 over 4 minus 5. 7 over 2, and then you attach pi. This is the same value sa previous one, yeah? Using the first method. This one. 7 over 2 pi. And so I hope that you have learned something. So it's very important sa labeling sa strip, okay? Whether it's vertical or horizontal strip. So just make sure that your labeling is correct. Values of x right, x left, y up, and y down. Okay. I hope that you have learned something from this presentation. Thank you for watching.